As- Assalamualaikum and a very good day. Today, me and my friends are going to present about Bmma 3503 vehicle brake system. So this is the lab 1, design and analysis of car disc brake system. So these are my group members, Husna Amani binti Muhammad Sairi, Muhammad Akmal Faiz bin Azli, Muhammad Ameer bin Ahmad Husaini, Darwish Ashraf bin Abdul Samad, and myself, Budriz Bin Berhaman. First off, we are going to start by the introduction. So, firstly, I'm going to introduce myself. My name is Budriz Bin Berhaman, and my metric number is B0921101119. And I'm going to start by the introduction, and I'm going to explain on what is going to happen in this lab session. So basically, for this lab session, we are going to create the disc brake in virtual reality. We are going to use the Katia V5 software because it will enable us to create the disc brake and define the material properties of the disc brake rotor. Lastly, we are able to analyze the disc brake rotor based on the brake force itself. So basically, in this lab session, we're going to use the Katia V5 software and we're going to design a disc brake system. And by that, we are going to put force on it, and therefore we are going to analyze on what is going to happen. That is all from me, and I will pass on to the next presenter. Thank you.
Hello, my name is Muhammad Faiz. I will continue in our presentation in theory. Okay, first thing, the brake pad. The first point is the resulting frictional contact slows and stop the disc and wheel. Okay, the second one, the caliper has one or more piston which when braking the hydraulic pressure will push the piston outward. Okay, and then about the disc rotor. The disc brake has a metal disc or rotor instead of drum. The pads are held in a caliper that straddle the disc. Okay, the next slide is to calculate factor of safety. Okay, the first point, a car's brake system plays a big role in the safety of the passengers, and therefore the need to calculate the factor of safety is important. Okay, the second one, the reliability of material is not 100%, and the load using in design calculation is not the maximum load. So the factor of safety or safety factor provide the protection against those unknown event to some extent. Okay, to find the safety of factor, we need to find the ultimate stress which is T max divided by allowable stress which is TW, and then we got the factor of safety.
For the drawing part, firstly we need to determine the shape of the disc brake, and then we need to measure the dimension from the drawing. After we draw the disc brake sketch using drawing that has been given, we need to convert it uh, we need to convert it to be a solid shape. After that, we need to draw a small circle for the screw hole, and then we use the function of circular pattern to duplicate it into the 5 hole for the screw. For the last step is to draw the surface of the brake pad, and then we can get the information about the pressure that has been given to the disc brake from the compression of the brake pad. So after we do some analysis on the disc brake with the brake pad surface, we got 6 data and finding. So for the first one, we got young modulus. So the value of the young modulus is 2 times 10 power of 11 Newton per meter square. And then for the Poisson ratio, we get 0.266. And then the density, we got 0.008 gram per millimeter cube. And thermal expansion, we got 1.17 times 10 power of negative 5 Kelvin. And then for the yield strength, the value is 2.5 times 10 power of 8 Newton per meter square. For the last part is the material. We use steel for this brake.
I will continue the presentation by doing the analysis. So first we go to analysis and simulation, then we select generative structural analysis. And then we select the surface that we want to clamp. And then we select the outermost surface as a surface slider, the front and the back. And then we apply the distributed force on the brake pad area, and the force is 2680 kilonewton, and we need to adjust the positive and negative sign to ensure the error is correct. So the arrow must be into it, just like this. And we apply the rotation force by select the whole parts and select the rotation axis. We need to ensure that the rotation axis must be correct. And the final step is we compute all the parts we analyze, and we can obtain formation stress data, translational displacement, and stress principle. And we click to the generate report to obtain all the data we need. That's all from me. Thank you. As for the experiment result, we have maximum von Mises stress 3.99 times 10 power of 11 Newton per meter squared, and the minimum von Mises stress is 2.06 times 10 power of 6 Newton per meter squared, and the last one is translational displacement, which is 403 millimeter.
Okay, for calculation factor of safety, which is we can find by ultimate stress, which is Tmax, divided by allowable stress, which is Tw, and then from the data we get in the CATIA from the simulation, the Tmax, which is ultimate stress, we got 2.5 multiplied by 10 power of 8, and then divided by allowable stress, 3.99 multiplied by 10 the power of 11, and then we got the factor of safety is 0.627.
Assalamualaikum warahmatullahi wabarakatuh. My name is Darwish Ashraf bin Abdul. Matrix number B0921100530. We'll continue on the discussion of our lab. Based on the results of the lab session, we found out that there is a huge difference between the yield stress of the rotor, which is 2.5 times 10 to the power of 9 Newton over meter square, while the ultimate von Mises stress is 3.99 times 11 Newton over meter square. From here, we can see that the rotor is really safe to use. When we insert both of these stress into the safety factor equation, it will result to a safety factor of 0.627, which proves that the rotor is safe to use. Von Mises stress and the safety factor are related in that the safety factor is determined by comparing the von Mises stress to the applied or permitted stress. The permitted or applied stress is often used to assess if a structure or component is safe under the specified loading circumstance. It is determined by applying design criteria, rules and standards. In conclusion, at the end of the lab session, we learned that designing a brake rotor is not simply just making a round-shaped metal and putting it on the car. Our lab session emphasizes the critical importance of thoughtful disc rotor design and material selection, all of which hinge on specific application. Before making these choices, it is imperative to accurately assess the maximum force the disc rotor will endure.
That is all from our group. So I would like to say thank you for listening to our presentation, and that's all from us. Thank you.